All right, so this is section 4-5, and we are looking at logarithms, and we are going to work on expanding and condensing logarithms. So just to review some of the rules that we went over previously in our notes in the previous sections, again, also change of base property. But the things we're going to use the most are these three right here. So remember that if we have two terms being multiplied here inside a single logarithm, then those can expand to addition. So going from one logarithm to two separate logarithms. Similarly, with division, we can divide two terms and those expand to subtraction. And then if we have a power on top of what's inside the logarithm, that power can move out front. Now we can also go the other direction. And if I have two logarithms being subtracted, I can condense that to division. If I have two logarithms being added, I can condense that to multiplication. And so that's what we're going to be using in these first couple examples here. I have these three examples that are asking me to expand this logarithm. And you can see a bunch of white out here. I started this video and then wasn't able to finish it, so I whited that out. That's why it looks a bit funny here. So we have x times y cubed. So I'm going to use my expanding properties and write that as log base b of x plus log base b of y cubed. And we are almost there. We have just one more step. My exponent, using that power rule, can come out front. And so this would be log base b of x plus 3 times log base b of y. And that is this logarithm expanded as much as it can possibly be expanded. In the next example, we have multiplication and division. So these terms that are being multiplied up top are going to be expanded using multiplication. Anything in the bottom would be expanded with subtraction because they're being divided. So if I had multiple terms in the bottom, in fact, you know what? Let's change this problem. Let's change this to, instead of just z squared, let's make it w to the 5th power and z squared, just so I can better display this. And let me go ahead and write that out one more time. That way it's a little bit clearer. So I have x cubed y up top and w to the 5th and z squared on bottom. And anything that's in the denominator is going to have a negative in front of it. Both of these terms are being divided. Both of these terms are being multiplied. So when I expand this x cubed and the y are going to have a positive sign in front. And these two terms that are in the bottom, when I expand it, are going to have a negative sign in the front. So I can go ahead and expand this to separate logarithms. Natural log of x cubed plus natural log of y minus natural log of w to the 5th minus natural log of z squared. So now I can move all of my exponents out front. And I have 3 ln of x plus ln of y minus 5 ln of w minus 2 ln of z. Right? And this last one here, we have natural log of all of these terms here. I have 100 times x cubed times the cube root of 5 minus x over x plus 3 to the 5th power. I'm going to rewrite this a little bit differently before I start expanding. I have 100 times x cubed times 5 minus x, and the cube root is the same thing as raising it to the 3rd power. And then I have x plus 3 to the 5th power on bottom. So I can go ahead and expand that entire thing, and I have a natural log of 100 plus natural log of x cubed plus natural log of 5 minus x to the 1/3, and then minus natural log of x plus 3 to the 5th power. And then the last step is just bringing all those exponents out front. So I still have natural log of 100 plus natural log, 3 natural log of x plus 1/3 natural log of 5 minus x, and then minus 5 natural log of x plus 3. All right. Sometimes I will have students ask why I separated the 100 and the x cubed. This cube here is only on the x. So I could not bring the 3 out front until I separated those terms because that exponent of 3 is not being applied to the 100. Another question I'll sometimes ask is, can we separate these terms? No. If you have something subtracted or added inside your parentheses, those are stuck together. If they were divided or if they were multiplied, then I could expand to subtraction. But if you have a single term here that's subtracted, I can't split that up. All right, so the next examples, we're going the opposite direction. We are condensing these logarithms. Sometimes you'll see those instructions saying write as a single logarithm, which means the same thing. And we go in the opposite order. So I am going to be moving my exponents back on the logarithm first. So this becomes log of x plus log of y to the 7th. And then those are being added. So condensing those logarithms is going to be with multiplication. So I have log of x times y to the 7th, and then that would be my answer. In the next example, again, I'm going to move those exponents back on there first, and that becomes natural log of x plus 9 to the 8th power minus natural log of x to the 4th power. And then that's subtraction, so it'll condense to division, and that becomes natural log of x plus 9 to the 8th power over x to the 4th power. Now, sometimes I'll have students ask me if they can write it like this, and if it means the same thing. ln of x plus 9 to the 8th power over ln of x to the 4th power. This is not the same thing. So you cannot write this way as two separate natural logs. It's condensing to a single logarithm. All right, and then this last one here, I have this 1/3 outside of these brackets, and so it's being applied to everything inside. So I'm going to work inside those brackets first, bringing these exponents, and that's actually just that one, back up top. And so I have ln of x plus 6 to the 5th power minus ln of x minus ln of x squared minus 25. And then I can go ahead and condense inside those brackets. So I have ln of x plus 6 to the 5th power over x times x squared minus 25. And now this power of 1/3 can be brought out onto the whole thing. But remember, a 1/3 power is the same thing as a cube root. So this would be ln cube root of x plus 6 to the 5th power over x times x squared minus 25. And that would be our answer. And that's the end of this very short section.